Hi guys, in this video I'm going to talk about graphs of trigonometric functions, which are sine, cosine and tangent. As you see, graphs of sine and cosine are similar to each other. They are like wave, and both of them are extending in both directions to the infinity with a regular pattern. Their domain and range are also same. Let's talk about domain of sine and cosine. So for domain, as you know, we have to look at the x-axis, possible x-axis. So since they extend in both directions to the infinity, domain is all real numbers, there is no exception. For range, we are focusing on our y values. Here, our highest y value, it is not clear in this picture, in this graph, but it's 1. Lowest y value here is -1. Same for cosine. 1 and -1. So the range is between -1 and 1 for both of the functions, because the highest point is 1, lowest point is -1, it's between them. So there's one more thing I want to explain here. The coefficient of sine and cosine here is 1. So that's parent function, the coefficients are 1. What happens if I change the coefficient? For example, let's say my function is not sine x. Let's say it is 2 sine x. So this coefficient represents how high and how low my function, my graph is. So if we have 1 here, as we have here in the function, it is 1 between 1 and -1. So if we have 2 here, our function will be, the graph will be between 2 and -2. So this coefficient also gives us an idea about the range. So we can say that the range here is, instead of between 1 and 1, it is between -2 and 2. You have some questions like that in your test bank in chapter 5 in domain topic. So I just want to remind you that. So let's talk about differences. These are the similarities. Let's talk about differences for sine and cosine. For function sine, x-intercepts and x-intercepts are different for sine and cosine. So here we have 0. The graph is passing through 0, pi, 2 pi, -2 pi, and so on. So the x-intercepts are pi's and their multiples. So sine x is equal to 0, where when x values are multiple of pi, we can generalize this as n pi, where n is an integer. So that's very important, very useful. Let's do the same for cosine. Let's figure out what x-intercepts for a cosine function is. So the x-intercepts here are pi over 2, 3 pi over 2, -pi over 2, -3 pi over 2, and so on. So when cosine x is 0, 0, our x values will be pi over 2 plus pi over 2 plus n pi. That's how we generalize the possible x values to make function 0. For sine and pi, for cosine, pi over 2 plus n pi. We're going to use this information, especially for grade 12. You'll need it. It's important. So let's move on to tangent function. So tangent is different than sine and cosine. The similarity is it extends in both directions to the infinity with the same pattern. The difference here is we have asymptotes for tangent. Your graphs never touch these asymptotes. What is asymptote? Let's remember that first. So as you know, tangent is equal to sine over cosine. Asymptotes are numbers that makes function undefined. So what makes this function undefined here? The cosine in denominator being equal to 0 makes the function undefined. So the cosine cannot be equal to 0. Denominator cannot be equal to 0. If it is, it's undefined. So numbers that make cosine 0 will make the function undefined, so there will be asymptotes in that point. So what are those points? Those points are, as we wrote here, pi over 2 plus n pi. So when you talk about domain, you are going to say that it's all real numbers except those numbers that make cosine 0. So all real numbers except pi over 2 plus n pi. That's what your domain is. What about range? For range, there is no restriction. Up and down, it goes to the infinity without any limit, so it's all real numbers. These were graphs of basic graphs of trigonometric functions. Let's continue with their transformations. We talked about transformations in chapter 5 in detail. Now I'm going to just go over quickly. In the first graph, you see the parent function sine x. The black one is the original function sine x. The red one is the transformed form of that. So what's the transformation here? We have plus 45 degree. The addition is inside bracket, which means we have a horizontal translation. There is horizontal shift. So we go 45 units to the left when we have addition inside bracket, which means we're going to go to left 45 degree. So we have to move our every point 45 degree to the left. So it was passing through 0 first. Now it's passing through negative 45 degree. It was passing through 180 degree. Now it's passing through 135 and so on. So every point will be slided to the left 45 degree. What about the other one? In the other one, we have plus 1. This addition is outside of the bracket. So it's not with function, it's without function. That means we have vertical change. So there is vertical shift. So we go 1 unit up. We will move our every point 1 unit up. It was passing through 1 first. That's the parent function, parent cosine function. Now it's passing through 2. It was passing through 0 here. Now it's passing through 1 and so on. So every point will be shifted 1 unit up. What else we have here? Here we have reflection. Now the green one is the parent function cosine x. The blue one is the opposite one. So opposite of cosine is negative cosine, which means we have reflection across x-axis. Wherever we have negative in front of the original function, we will have reflection across x-axis in this function. So there is a mirror on the x-axis. So if we have the graph above the axis, the image will be below the x-axis, the image will be above. There's graph above the x-axis, the image will be below. The graph is below the x-axis, the image will be above. So what happens if we have negative inside the function? The negative is with x, not in front of the function. In this case, we're going to say that it is reflection around y-axis. Okay, that's all for graphs of trigonometric functions. Now let's move on the other topic, trigonometric equations. You don't have this one as a topic in your book, but we have many questions that needs you to know this topic. So I want to show you how to form. So let's take a look at the first question. What are the possible x values that make sine 0? It's like the first part that we learn here. How we generalize sine x. We generalized the numbers that make 0s and pi for cosine, pi over 2 plus and pi. We're going to use that to solve questions here. So for sine and pi. So what is your x here? Our x here is pi over 2x. Pi over 2x. We need x alone. Isolate x by multiplying both sides by 2 over pi. So you have x is equal to 2n. These are 2n values are that makes sine 0 here. What about cosine? So how did we generalize cosine? It is n pi plus pi over 2, which is equal to our x here, the number written right next to cosine is x over 2. We need x alone, so get x by itself by multiplying both sides by 2. So x will be 2n pi plus pi. These are values that makes cosine 0. Let's move on with other type of questions. So here, unlike the other two questions, we don't have 0. We have another number here, 1 over 2. What makes sine 1 over 2? So we can find the numbers that makes sine 1 over 2 by using inverse sine. So sine inverse of 1 over 2 is equal to x. So by using the calculator, you can find it easily. So x is going to be here 30 degrees. But it doesn't necessarily mean that your solution is 30. It doesn't mean that. Because we are given that we have to find x values in this interval from 0 to 2 pi. So all of the coordinates are possible. We are going to check all of the coordinates. So what can you say about its sign? It's 1 over 2, so it's positive. So in which quadrants we have positive sign? So in the first quadrant, sign is positive. In the second quadrant, sign is positive. So in the first quadrant, as you found here, your angle is 30. So what is your angle in the second quadrant? In the second quadrant, what you found here is your reference angle. Your reference angle is 30. What about your original angle? You'll find your original angle by using the formula. What was the formula? The formula was 180 minus reference angle in the second quadrant. 180 minus 30, which gives you 150. So here you have two possible answers, 30 degree and 150 degree. 30 and 150. You don't see these two in options. They are all written in terms of radians, so convert them to radian. So 30 will be pi over 6. 150 will be 5 pi over 6. You can do steps. I am skipping these steps here. So your answer is B. Let's do the same for the next question. This time your cosine is negative. Cosine is negative in which two quadrants? In which two quadrants your cosine is negative? So here in the second quadrant and in the third quadrant your cosines are negative. So let's find their reference angle first by using inverse cosine here. So inverse cosine of square root 3 over 2 is equal to, you are not using negative here because this negative represents the location of the angle. So no need to use that here. It will give you the wrong result. So inverse cosine of square root 3 over 2 will give you 30 degree. Your reference angle is 30. Be careful. It is your reference angle, not the original angle, not your answer, not your solution. It's the reference angle. So in the second quadrant, your reference angle is 30. In the third, also 30. So now you have to find your original angles. Your original angle in the second quadrant, 180 minus 30, which is 150. In the third quadrant, 180 plus, it is further from 180, so you are adding plus 30, which is 220. So you have two solutions, 150 and 120. So 150 degree and 220 degree. You convert it to radian, which will give you 5 pi over 6 for 150, for 220, 7 pi over 6. You have two solutions. The solution is B. So that's all for this section.